This particular challenge statement refers to a problem that literally hundreds of pharmacists face on a daily basis. So imagine if you're in hospital and you're ready to be discharged and you're waiting at your bed for your medications before you pick them up and go home. So typically a pharmacist would come from a central pharmacy to bring the medications to you and explain to you how you should take your medications, and then you can answer any questions that you might have or clarify any statements. So that's the problem statement, because we have hundreds of patients being discharged every day, and pharmacists need to walk and to the wards and dispense these medications throughout the day. And this is highly inefficient if you consider the number of dispensations that we do on a daily basis. Next slide, please. So I just described the current process earlier. Next slide. So just to go into a bit more detail, what actually happens in the pharmacy even before the medications are given to the patient is that the pharmacy staff needs to request for the medications via the portering system. They fill up a manual form and they place the medications in the pigeonhole, right? And then next thing, the porter comes by and using the central portering system, using a smartphone. And the porter then goes to the pharmacy and picks up the medication and scans the barcode for the location. They need to verify the medications are picked up and update the smartphone, and then ensure that items that are in the fridge are placed in bags and sign off a manual form, in which case then he takes the medication to the wards and finds a nurse to receive the medications, right? And then the nurse needs to sign a takeover form and the nurse will do the dispensing. Next slide. So some examples of things that during the inpatient supply that are required to be sent to patients. So as you can see, they are all various sizes. They're not just tablets, right? They include bottles, mixtures, sometimes dressing, sometimes even cartons of milk feeds. Next slide, please. So a lot of these processes are actually redundant. So the ones highlighted in red. So for example, requesting for medication delivery by the portering system, filling up the form, the porter verifying the correct medications, signing manual forms. Then they have to look for a nurse who's available to receive the medication, and the nurse then needs to sign off yet another manual form. In fact, all of these processes can be automated by a proposed solution that we'll come to in a minute. Next slide, please. And the manual processes that we mentioned here are actually quite error prone. There's a risk that the porter may sign off on medications for a wrong patient, for example. So ideally, there should be a more deterministic method of confirming the medication delivery. Next slide, please. Certainly for the nurses on a day-to-day basis, they are already quite busy with a great number of things, and when they need to meet the porter to pick up the medications is very, very disruptive for them. So ideally, there should be a better method in delivering the medication straight to the patient. Next slide, please. So this is some statistics for our porters, right? So these porters walk in between pharmacy and the wards to deliver medications. And what's interesting here, of course, is that the peak period is in the morning when patients are being discharged through to about midday. And then in the evening, the second peak where porters need to deliver medications to the ward for patients who are again going to be discharged, or they're delivering medications for other purposes, right? And these numbers exclude what we call station porters, porters that are supposed to be stationed in particular places. Next slide, please. So the average number of jobs per day, varies. It's about the same, but typically we see peak on Sundays and Wednesdays purely because of the pattern in which we do patient discharges. Next slide, please. So, and of all the portering jobs, 10% of them are urgent. So this really disrupts the porter's workflow because they have to drop everything and deliver specific items that are urgent. And then 10 to 15% of them are cold chain items, which require some form of a cooler bag to bring around. And the number of calls related to medications not found, the incidence is pretty low, about 1.5 times per month or twice, 3 every 2 months. So this requires the porter to troubleshoot because they failed to find and deliver the correct medication. Next slide, please. So some of the proposed solutions include, next slide. So we desire a simple, intuitive, and automated method of delivering the medications from the pharmacy to the wards. This should be efficient and be secure. In other words, the right medication needs to be delivered to the right patient. And of course, it should be cost effective and feeds off real-time information. Now I'll make a little reference to the asterisk at the bottom. We in NUHS, we are transiting to what I call the next generation electronic medical record, which is the EPIC system. There will be some amendments to these steps with NGMR implementation, but largely it will still be the same process where medications need to be correctly delivered to a particular location, and then the porter or the device needs to send these drugs to the wards. Next slide, please. Next slide, please. Thank you. So we would like the solution to be scalable and flexible. So the pharmacy actually may have multiple locations with different operation hours. And there's of course limited space within the pharmacy. So what we envision here is a pickup place for medications. The device, or I'm just going to say that the suggested proposed solution is a robotic solution, should be able to transport medications of various sizes, including milk feeds, some of which may require some refrigeration and not be exposed to heat sources. In terms of portering requirements, the robot that is supposed to move these medications should be capable of autonomous navigation. There's a retrofit requirement for lift doors and wireless networks. Let me explain what this means. So instead of having a really complex device robot that is able to open doors and press lift buttons, we actually would want the solution provider to integrate some form of automated door opening and lift requesting feature, so as not to spend a lot of effort developing robots that are able to press a lift button, for example. So it needs to be able to be autonomously navigate through public areas such as the hospital walkways, to avoid things like beds and trolleys, and able to solve problems like tight spaces. And of course, as a central system, you should be able to prioritize jobs based on the logic determined by the users. So in the wards, you may need multiple locations for drop-off and to interact with users for selected items, and have some form of access control to the medications deposited within the robot. For example, you have drawers that open with only the patient's correct ID. And of course, the dashboards to control and monitor the robot's functions should be configurable by the users. Okay, so I come to one of the key features of this particular challenge statement is that this robot should be modular. So one of the problems we faced when we looked at solutioning for these kinds of robots will be that the battery module has a limited lifespan, and needing to maintain a fleet of batteries of robots that are redundant and sitting and charging, it's not ideal. So what we would like to have is a base module that looks after navigation and control, and a battery module that is within it that allows you to have automated hot swaps, and of course the functional module that is configurable for the use case. And in this particular use case, it will be for medication delivery. And finally, the interfaces, it should interface with the upcoming NGMR system and exchange information specific to container ID and location information for medication supplies. That is, it should then corroborate the order to what is actually being delivered to the patient. Next slide, please. So other use cases for such a platform, remember we mentioned something about flexibility and modularity. There'll be occasions where medications that are delivered is too much in quantity because the patient already has some medications at home. So the robot should be able to return the medications from the wards to the pharmacy. Of course, the use case was to deliver the discharged medications to the ward. Delivery of outpatient take-home medications to designated locations or stations within the hospital. In other words, there are some take-home medications for example, day surgery patients that are just simple painkillers, and this should be able to be delivered to specific locations that allow patients to just pick it up without needing to wait at a pharmacy. And the delivery of medications between pharmacy, clinics, and store locations in off-peak hours is to maximize the use of the robot in off-peak hours. And of course, cross-functional use cases by other departments. So for example, other departments may have other use requirements. Take as an example, the laboratory medicine often have use cases to deliver, say, blood specimens to specific places that are not normally covered by hospital tube systems. So we still rely on porters to, say, deliver certain blood tests to the ward by hand. Next slide. Okay, so that ends my presentation. I'll be happy to take questions.
Thank you, Professor. I think it was a very, very good presentation. So let's see if we have a question. Yeah, so we have one. The question is, for all these medical solutions from challenges, are you looking for a cloud solution or on-premise? Also, if there are integration with the existing system, what will be the integration interface? Like, for example, SAP or anything like that?
Okay, that's a great question, Mike. So the solution we are looking for here is a cloud-based solution because based on the current parameters for the robot, a lot of the functions are actually going to be residing on the cloud. So we are looking for a cloud-based solution at this point. In terms of integrating with the backend EMR system, you have to interface with our current systems that is able to pipe certain data to the robot via a dedicated communication link. So what I mean here is that the information would be received by the robot in terms of its EMR delivery information via a dedicated communication link. But for the rest of the function of the robot, it would be fully within the internet space.
Thank you, Professor. Next question is it necessary to have refrigeration on the robot, or can it be replaced in a cooler bag instead?
It's not necessary. A cooler bag is sufficient because we are talking about short distances between the pharmacy and to the patient. Yeah.
Okay. Any other question from the audience? We have one more. Do we need to comply with any communication standards such as RMF?
Yes, absolutely. So the robot currently will be connected via Wi-Fi connection to the cloud. So Wi-Fi to the robot and then to the internet.
Thank you. I think the last follow-up question is the delivery is to the patient or the nurse in the ward?
Thank you for that question, Derek. That's a great question. So I think for this particular use case, our initial aspiration is to be able to deliver to the ward nurse. However, going forwards with more development, we hope to be able to get the robot to actually do the prescription dispensing of the medications, so that frees up the nurse from doing the dispensation. And this can be done in two forms. At the very base will be some form of pharmacist telepharmacy kind of dispensation, where the robot will act as a telepharmacy module to deliver the medications to the patient. And of course, the more advanced form, which we are working on as well, is to use a chatbot-based dispensation of the medications directly to the patients.
Cool. Derek also asked, you mentioned pickup location. So does that mean the patients must be at the pickup point?
Yeah. So Derek, I might answer these questions directly. So there are two modes of operation. So the vast majority of the patients in this use case will be in the wards, in their beds. So this means that you'll be delivered to the wards or to the actual individual beds where the patients are. There's another use case where there are patients who are just simply like day surgery patients, minor cases, they're sitting on like chairs, for example, right? So when they want to leave, typically now they have to go and queue at a pharmacy for about an hour just to pick up their medication. So it might be ideal that the medication is just delivered either directly to them or to a place where they can just pick up simple pain medications that do not need dispensation.
Thank you, Professor. And let's take the last question. So Mike, regarding his previous integration question, he's also asking, does this also apply for C3 system or OTMS and BMS, similar to API integration?
Thank you, Mike. That's a wonderful question. So ideally, we would like to have the same C3 system that monitors not just OT functions, but also things like robot functions. So in that particular use case, we are actually looking for a platform level solution for C3 that can integrate multiple sources of information to achieve whole of hospital command and control.